You pop 2 ibuprofens, sip warm tea, and complain to your phone that you've been sidelined by a mild head cold. Within 45 minutes, your fever drops, your headache vanishes, and you're back to scrolling. We take this routine so completely for granted that we rarely stop to ask a terrifying question. For 99% of human existence, there were no pharmacies. No sterile band-aids, no blood tests, no synthetic antibiotics. Not even a basic understanding that microscopic organisms called bacteria and viruses existed. If you got a tooth abscess in the Pleistocene, there was no dentist. If you got a deep gash on your thigh while hunting a bison, there was no neosporin or stitches. If you drank contaminated river water, there was no emergency room to pump fluids into your veins. To a modern observer, the Stone Age looks like a biological death sentence. One bad infection, one stomach parasite, or one broken bone should have wiped out an entire band of hunter-gatherers. And yet, here you are. You exist because an unbroken chain of tens of thousands of generations of ancient humans got sick, got injured, caught infections, and somehow, against every physiological probability, figured out how to survive them. How? The popular myth is that ancient medicine was nothing more than superstitious tribal dancing and blowing smoke into people's faces. But over the last decade, groundbreaking advances in genetics, bioarchaeology, and ancient DNA analysis have shattered that myth. What scientists are discovering in ancient teeth, fossilized bone, and 50,000-year-old cave floors isn't primitive ignorance. It is a story of incredible biological trial and error, Stone Age neurosurgery with 80% survival rates, and an evolutionary superpower that saved our ancestors long before modern science was ever born. For centuries, medical historians thought we would never know what ancient humans actually took for pain or illness because plant matter rots. Wood, leaves, and fungi dissolve into dirt within years. Then, geneticists realized they were ignoring one of the greatest biological archives on Earth, dental calculus, the hardened, calcified plaque stuck to ancient human teeth. When an ancient human chewed on a leaf, root, or mushroom, microscopic fragments of food, plant material, and bacteria got trapped inside their tooth plaque. Over decades, that plaque mineralized into rock, sealing ancient biomolecules inside a microscopic vault for tens of thousands of years. In 2017, a team of researchers led by paleomicrobiologist Dr. Laura Wyrick analyzed fossilized dental calculus from Neanderthals who lived 48,000 to 50,000 years ago in El Cedron Cave in northern Spain. One young male Neanderthal specimen stood out. His jawbone showed clear physical evidence of a massive, agonizing dental abscess. To make matters worse, his tooth plaque contained the genetic signature of Enterocytosome bianusi, a nasty single-celled gut parasite that causes severe, exhausting diarrhea. This Neanderthal was profoundly, miserably sick. But when Dr. Wyrick's team sequenced the DNA trapped in his teeth, they found something mind-blowing. Unlike the other healthy Neanderthals in the cave whose teeth contained remnants of pine nuts, moss, and wild mushrooms, this sick Neanderthal's teeth contained two very specific, non-food substances: poplar bark, populus, which naturally contains high concentrations of salicylic acid, the active ingredient in modern aspirin, and penicillium mold, the exact fungus that produces penicillin, the world's first natural antibiotic. Think about what this means. Nearly 50,000 years ago, tens of thousands of years before the birth of Alexander the Great, the Egyptian pyramids, or Alexander Fleming's laboratory, a sick Neanderthal suffering from a tooth infection and a gut bug went out into the forest, selectively harvested plant bark containing a painkiller, and consumed moldy vegetation containing natural antibiotics to treat his specific illness. This wasn't random chewing. Healthy Neanderthals in the same cave showed zero traces of poplar or penicillium in their teeth. This individual was targetedly self-medicating, and this wasn't an isolated case. Fast forward to 1991, when hikers in the Ötztal Alps discovered Ötzi the Iceman, a naturally mummified human who died around 3,300 BCE, over 5,000 years ago. When scientists examined Ötzi's preserved gear, they found 2 strips of leather hanging from his pouch, each threaded with a dried, woody mushroom known as the birch polypore. For years, archaeologists wondered why an alpine traveler would carry heavy dried fungi across icy mountain passes. Modern pharmacology provided the answer. Birch polypore contains toxic oils that are lethal to intestinal parasites, as well as potent anti-inflammatory compounds. And when scientists analyzed Ötzi's digestive tract, they found his intestines were heavily infested with Trichuris trichiera. Ötzi was carrying a specialized, portable anti-parasitic kit, custom-matched to the exact parasite living in his gut. Even stranger were Ötzi's tattoos. He had 61 small tattoos etched into his skin, not decorative art, but precise groups of parallel lines located directly over his lower spine, knees, and ankles. Radiographs revealed that Ötzi suffered from severe osteoarthritis in those exact joints. A study published in the Journal of Archaeological Science mapped those tattoo locations against traditional acupuncture maps and found that 80% of Ötzi's tattoo marks correspond precisely to modern acupuncture pressure points used to treat joint pain and stomach distress. 5,000 years ago, humans were already combining botanical pharmacology with physical medical interventions. Herbal remedies are one thing, but what happened when an ancient human suffered something structural? A crushed skull from a hunting accident, a severe head trauma from intergroup warfare, or blinding pressure headaches? They performed neurosurgery. Long before sterile operating rooms, rubber gloves, or anesthesia existed, ancient humans practiced trepanation, the deliberate drilling, scraping, or cutting of a hole into a living human skull. Trepanation is officially the oldest documented surgical procedure in human history, with physical evidence stretching back to the Mesolithic era, over 10,000 years ago. Archaeologists have unearthed trepan skulls across every continent, from France and Ukraine to Peru, China, and North Africa. How do you scrape through a human skull with nothing more than a razor-sharp piece of flint or obsidian without instantly killing the patient? Very carefully. Using stone tools, Stone Age surgeons would peel back the scalp, bypass the major blood vessels, and slowly scrape away layer after layer of cranial bone until they reached the dura mater, the protective membrane surrounding the brain. This released internal bleeding, relieved intracranial pressure caused by fractures, and removed shattered bone fragments. Now, your instinct is probably to assume that 99% of people subjected to a Stone Age skull drilling died of brain infections or massive hemorrhaging. The physical evidence proves the exact opposite. In bioarchaeology, bone tells the truth. If a patient dies during or immediately after surgery, the edges of the cut bone remain sharp, raw, and jagged. But if the patient survives, the human body immediately begins rebuilding bone, smoothing out the sharp borders of the hole over months and years. When archaeologists examine prehistoric trepanned skulls, between 70% and 80% show extensive bone remodeling and smooth regrowth. In ancient Peru, Incan surgeons performed thousands of trepanations. By analyzing skull collections across centuries, researchers discovered that their survival rates actually increased over time, rising from 40% in early eras to over 80% by the 1400s. For context, during the American Civil War in the 1860s, thousands of years later, battlefield skull surgeries in modern military hospitals had a mortality rate exceeding 50%. Stone Age hunter-gatherers and ancient Andean surgeons were outperforming 19th century hospital surgeons because they understood 3 critical things without ever seeing a microscope. Keep it clean. They washed wounds with antiseptic natural fluids like boiled water, salt water, or plant resins. Protect the dura. They knew never to puncture the brain membrane. Speed and precision. Stone tools like obsidian, which is up to 30 times sharper than modern surgical steel, sliced through tissue cleanly without crushing surrounding cells. Herbs and flint scalpels explain how ancient humans treated physical ailments, but they don't answer the bigger mystery. In a harsh, nomadic Pleistocene environment, where every calorie was earned through intense physical labor, what happened when someone couldn't hunt, couldn't gather, and couldn't run? In a pure survival of the fittest world, an injured or chronically sick individual is a burden. They consume precious food, slow down migrations, and cannot defend the group against predators. Logical evolutionary logic says they should have been left behind. The fossil record proves we didn't do that. In 1957, archaeologists excavating Shanidar Cave in the Zagros Mountains of northern Iraq discovered the fossilized remains of a Neanderthal male known to science as Shanidar I. When forensic anthropologists examined his skeleton, they were horrified by what he had suffered during his life. As a young adult, he suffered a crushing blow to the left side of his face, fracturing his orbit and leaving him completely blind in one eye. His ear canals were blocked by bone growths, rendering him deaf. His right arm had suffered multiple severe fractures, withered away completely, and was severed above the elbow. His right foot and lower leg suffered severe trauma, causing a crippling, painful limp. Shanidar I was blind in one eye, deaf, missing half his right arm, and could barely walk. In the Ice Age, he was completely incapable of hunting game, sprinting from predators, or trekking long distances alone. Yet bone analysis revealed something extraordinary. Shanidar I lived until he was roughly 40 to 50 years old. In Neanderthal terms, that was an advanced, elderly age. His severe injuries had fully healed decades before his death. That means, for 15 to 20 years, his social group carried his load. They hunted for him. They chewed his food when his jaw hurt. They protected him from leopards and wolves he couldn't see or hear coming. They carried him across mountain passes. This isn't an anomaly. Archaeologists call this the bioarchaeology of care. At the site of Cima de los Huesos in Spain, researchers found the 500,000-year-old skull of a child who suffered from craniosynostosis, a rare birth defect causing severe facial deformity and developmental delay. The group nurtured and protected this child until age 10. At Man Bach in Vietnam, a 4,000-year-old skeleton belonged to a young man paralyzed from the waist down by a congenital disease. He required total daily physical care, washing, feeding, turning to prevent bed sores, for over a decade before he died. Our ancestors did not survive because they were the strongest individual predators on the savanna. Physically, humans are slow, fragile, and hairless. We survived because we transformed empathy into a biological defense system. Caregiving wasn't a luxury we invented after becoming civilized. It was the fundamental strategy that made us human in the first place. Here is the ultimate historical twist that almost nobody expects. If you ask most people when human health reached its lowest point before modern medicine, they assume it was the Paleolithic Stone Age. They picture cold caves, rotting teeth, and constant sickness. The bioarchaeological data tells a completely different story. For hundreds of thousands of years, nomadic hunter-gatherers were surprisingly healthy. They lived in small, scattered bands of 20 to 50 people. They moved constantly, leaving their waste behind. They drank fresh spring water and ate a hyper-diverse diet of hundreds of wild plants, berries, seeds, game, and fish. Most importantly, they didn't have crowd diseases. Measles, smallpox, influenza, cholera, tuberculosis, and bubonic plague didn't exist in the Deep Stone Age. Those pathogens require two things to survive: high-density human populations like cities, and constant intimate contact with domesticated livestock like cows, pigs, ducks, and horses. Then, roughly 10,000 years ago, humans invented agriculture. We settled down. We built dense villages. We slept next to our livestock, drinking water contaminated by animal runoff. We replaced a diverse diet of 150 wild plants with a monocrop diet of starchy wheat, barley, or rice. The results were catastrophic. Average human height plummeted by 4 to 6 inches. Cavities and tooth loss skyrocketed due to starchy grain diets. Bone lesions from chronic anemia and vitamin deficiencies multiplied. Infant mortality exploded as zoonotic viruses jumped from livestock to humans. Agriculture gave us civilization, cities, and written language. But it also created the exact microbial nightmare that plagued humanity for the next 10,000 years. The Stone Age hunter-gatherer wasn't a sick, parasite-ridden creature living in filth. They were a lean, highly mobile survival expert who used nature's cabinet, practiced sterile bone surgery, and took care of their wounded. The next time you swallow a pill, wrap a bandage around a cut, or sit by the bed of a sick child, take a second to look beyond the plastic packaging. You are performing a ritual that predates our entire modern world. Your body is running software calibrated by 300,000 years of adaptation. The impulse to seek out bitter plant medicines, the physiological reflex to rest and shiver, the deep emotional urge to comfort someone who is hurting. None of that was taught to you by a textbook. It was carved into your DNA by an unbroken chain of ancestors who sat around Ice Age campfires, chewing poplar bark for a toothache, scraping skulls to relieve pressure, and spending weeks nursing a broken friend back to health in a dark cave. They didn't have modern science, but they had observation, they had courage, and above all, they had each other. If you made it this far, you are exactly the kind of person this channel exists for. We make videos like this every week exploring ancient human behavior, evolutionary biology, and the hidden stories written into our species' past. If that's something you want more of, hit subscribe. It costs you nothing, and it tells the algorithm that deep, storytelling-driven science is worth keeping alive. See you in the next video.